Finding all the side lengths and angle measures of a triangle can be tricky, particularly if it's not a right triangle. That's where the law of sines comes in. Welcome to Math Bytes, I'm Allison, and today we're talking about the law of sines. An oblique triangle is any triangle that doesn't have a right angle in it. We can use the law of sines for an oblique triangle if we know two angles and a side, or two sides and an angle opposite one of those sides. So here it is. Where capital ABC are angle measures and lowercase abc are the side lengths opposite those angles, the law of sines says that A over sine A equals B over sine B equals C over sine C. Let's do an example and see how the law of sines works. For triangle ABC, we're given that angle A is equal to 110.5 degrees, side A is equal to 53.3, and side C is equal to 25.4. So according to the law of sines, A over sine A is equal to C over sine C. And plugging in what we know, we get 53.3 divided by the sine of 110.5 degrees is equal to 25.4 divided by the sine of angle C. Now we can cross multiply, and we get 53.3 times the sine of angle C is equal to 25.4 times the sine of 110.5 degrees. Now let's divide both sides by 53.3 so we can solve for the sine of C. So we get that sine C is equal to 25.4 times the sine of 110.5 degrees divided by 53.3. Now, when we do that calculation, we find that the sine of C is equal to 0.44636,91108. Now we're going to use our inverse sine function to find out what C is. So we will get that C is equal to the inverse sine of that value, and that gives us that angle C is approximately equal to 26.5 degrees. Now, the inverse sine function finds the acute angle. There's also an obtuse angle with that same sine value, and it will be the supplement of the angle we just found. So the other angle possibility is 180 degrees minus 26.5 degrees, which gives us 153.5 degrees. Now remember, the interior angles of any triangle add to 180 degrees. Now we have to check and see if both of these angle measures are viable solutions. So in the first case, where C is equal to approximately 26.5 degrees, that means that angle B would be 180 minus 110.5 minus 26.5, which gives us approximately 43.0 degrees. That's fine. In our second case, where C is approximately 153.5 degrees, that means that B would be 180 minus 110.5 minus 153.5, which is approximately negative 84.0 degrees. We cannot have a negative angle measurement, so this is not a possible solution. So the only possible solution for our measure of angle B is approximately 43.0 degrees. So let's finish out the problem. The law of sines says that A over sine A equals B over sine B, and plugging in what we know, we get 53.3 over the sine of 110.5 degrees is equal to B over the sine of 43.0 degrees. That gives us that B is approximately equal to 53.3 times the sine of 43.0 degrees over the sine of 110.5 degrees. And when we do that calculation, we find out that side B has a length of approximately 38.8. When using the law of sines, the problems can be lengthy and a bit involved. It's very important to do that check where you see if your possible angle measurements are viable or not. Some problems have one solution, some problems have two solutions, and some problems don't have any. That's it for this episode of Math Bytes. If you like our videos, please subscribe to our channel. And if there's something you'd like to ask us, just send us an email. We're at contactmathbytes@gmail.com, and we'll see you next time.